All right, welcome everyone. This week we're going to talk about more limits and specifically limits of complex fractions like the one you see here in this example. Remember what we did last week. So here's some of our notes. We talked about some complex limits with trig functions and also some limits evaluating by the conjugate. Also, we saw some where you had to rationalize. That was this one right here. We had to rationalize and multiply. We saw some where you had, this was the conjugate, number 2. Let's see, number 4, we had to expand and simplify. And so if you watched, or if you came to class, you got my little spiel about when you get the 0 over 0 case. There are really 4 things that you want to do. The first is factor. And if you can't factor, sometimes you might have to expand. And so what I mean by factoring is simplify to cancel, so factor to cancel. And this one's expand, not expand, expand. Expand, so that's something like maybe you have x minus 2 squared or something like that, and you have to expand it out to x squared plus minus 4x plus 4. So that would be expanding, and then you could have to multiply by a conjugate. Or I'm going to say slash rationalize. And then the last one is what we're going to do today is complex fractions. So complex, I won't say complex fractions, but I'll just say common denominator. Denominator, there we go. And so anytime you see this particular case, you're going to want to use one of these 4 methods. So in this case, in a limit. So the limit, just one moment. Okay, so here, anytime you see a limit going to a specific value of your function and you end up getting 0 over 0, then you want to do one of these four things in order to simplify. And we've already seen examples of each one of these except the common denominator. So that's this lesson today, this unit 9, day 5, or week 7. So let's go ahead and get started. So the first thing that you should always do with these limits, hopefully you remember, is try to plug it in. You should always try that first. So let's go ahead and give it a try. We're going to get 1 over 4 minus 1 over 4 over 3 minus 3 is 0 over 0. So this means we have to do more work. More work. So let's go ahead and erase what we've done here and try it again. So this time, let's start by rewriting the limit because just plugging in didn't work. So we have to rewrite the limit now. Anytime you try to plug in and you get 0 over 0, you have to do some other things. So we're going to first rewrite, and then let's do a common denominator. So this x plus 1 factor here is going to need a 4. So I'm just getting a common denominator in the numerator between these two fractions, so a minus 1 over 4, and then I'm going to multiply this 1 over 4 by x plus 1. And this is all over the x minus 3 factor. Okay, now let's, so you want to simplify in this next step. So you don't want to plug in the 3 yet here because we really haven't changed anything. So let's rewrite the limit. We still can't plug in. We have to rewrite. Let's simplify. So here, this negative is going to distribute to both of these terms in the numerator. So I'm going to have a minus x and a minus 1. And then this is all over the common denominator of 4 times x plus 1. And then this is all over, so this is our ugly fraction in the numerator, all over an x minus 3. Let me just check that my power level is up. Yep, okay. So let's simplify. You don't want to plug in just yet again. You still have to simplify. So this is just a bunch of algebra that we have to do. So let's keep going. We're going to get a 4 minus 1 is a 3 minus x all over a 4 times x plus 1. I'm going to leave this 4 times x plus 1 expanded, but I am going to multiply by the reciprocal of this fraction in the denominator. So notice this x minus 3 in the denominator, it doesn't look like a fraction, but we can turn it into one by writing a fraction bar and putting it over 1. So now it's a fraction. And then if I just multiply by that reciprocal, this is going to flip it, so x minus 3. Okay, so I just flip and multiply there. And so let's do one more step before we actually evaluate the limit. So I'm going to rewrite that limit. I know it's a pain to rewrite it, but we have to keep rewriting. I would like it if this x minus 3 could cancel with this 3 minus x, but they're not quite the same. So what we want to do is factor out a negative. So we'll pull a negative out of the numerator, and we're going to be left with an x minus 3. And in the denominator, let's fix that fraction bar. In the denominator, we're going to have a 4 times x plus 1 times this one, and x minus 3. And this 1 just multiplies up here in the numerator, so you could put a times 1 up there, but it's not necessary. Okay, and so now notice what happens. We have this x minus 3 factor that we can finally cancel. Now is a good time to try to plug back in. So let's go ahead and try to plug back in this last step here. So I'm not going to rewrite the limit because I'm plugging in the x equal 3 into what's left over. And we have a negative 1 in the numerator, since there's really nothing left up here. And a 4 times, this is going to be a 3 plus 1. And this is gone, so this is it. So if I simplify this, we get a negative 1 over 16, and this is the final answer. So that's quite a bit of work there, and it mainly was algebra. So each one of these steps was just common denominator and simplifying. This is kind of a tricky algebra step here. I don't like fractions over fractions, so multiplying by a reciprocal is a good idea. So we're going to see that the process, the good news is the process is almost exactly the same as this process every single time. So all the examples that we're going to see here are going to be very similar to what we've just seen. So let's try another one. So here, number 1, let's start by plugging in 0. You should always start by trying to plug in the value. So we get 1/4 minus, this should be a minus, 1/4 all over 0, and we get 1/4 minus 1/4, or 0 over 0. So sometimes the reason that we have to check this case is because if it's not in this case, say we get some number, then you are done. So we want to check that it's actually in that indeterminate form before we continue. So let's go ahead and first try to get a common denominator between these two fractions in the numerator. If you want to simplify your work, you could even just write an x plus 4 here in the numerator of this fraction and a 4 in the numerator and denominator of this fraction. So that way we save ourselves writing a whole step here. So let's just write limit as x goes to 0. This fraction is going to be a 4 over 4x plus 4. And this one's going to be an x plus 4 in the numerator over a 4x plus 4 in the denominator, all over x. And now we have a common denominator, so we can combine the numerators. So let's go ahead and do that in the next step. We have to keep rewriting this limit. We're not able to plug it in yet, so we have to keep rewriting it. It's like it's waiting. This limit's just waiting out in front until we can plug in. And so you want to plug in as soon as you get some type of cancellation happening, like we saw here with the x minus 3. So let's go ahead and simplify these fractions. We're going to get a 4 minus x minus 4 all over a 4x plus 4. So if you're observant, you noticed here that I distributed this negative sign between these two numbers. So notice I've got two negatives in between those two. So there's like a parentheses here. The fraction bar is a grouping term, or a grouping symbol. So it groups the x and plus 4 together. So we have to distribute that negative through there. So the parentheses aren't necessary because we have the fraction bar. The parentheses are implied. So the negative gets distributed, and let's go ahead and put this all over x. And I don't like fractions over fractions like this. It's super ugly. So what I'm going to do is I'm going to write this x as x over 1, and then I'm going to multiply by the reciprocal to get rid of a fraction over a fraction. So let's do that in the next step. I'll simplify the numerator as just negative x, and the denominator is x plus 4. Let me show the cancellation of this 4. And then we want to multiply by the reciprocal of that x there is just 1 over x, like that. And we'll see some cancellation here as well. So this x is going to wipe out. So we get a lot of cancellation. So let's just go ahead and write the whole limit one last time before we evaluate. You could evaluate in this step right here if you want, but I'll simplify it first. And now let's try to plug in. So we'll try to plug in that 0. And we're going to get a very similar answer to the last problem. Negative 1 over 4 times 0 plus 4, which is negative 1/16. Now, both of these are doing something very similar. They're both finding what's called the derivative at a specific point. The only difference is where that point's at and what function we're thinking of. But that's for calculus when you get there. So notice that the process, though, is very similar in both cases. We're finding a common denominator, simplifying, canceling, and then plugging in. So here, this next step is going to be basically a calculus process. And I think what I'm going to do here is, let me just double check how many examples we have so that I don't run out of time. Yeah, we have 5 examples, so I think we have plenty of time here. We're maybe 10 minutes in, 12 minutes in. So let's go ahead and I'm actually going to explain a little bit about this formula before we start using it. So I could just dump this formula on you and say, here it is, but I think I'm going to actually take the time to explain it out a little bit. So this is an idea from calculus, and the idea is called the derivative, and the way that we write it is we put a little apostrophe. This is called the definition of the derivative, and so we put this little apostrophe here indicating that this is a new function. This is called f prime, or the derivative of f, and the way that it's written is just the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, this looks strange, so I think what I'm going to do is maybe explain what it's doing. So here is a point x on the x-axis, and here's the y-axis, and let's draw a nice function f. Here's our function f. And think of h, I'll draw it in green, as just a little bit. So h here is just a small number. I'll draw it like this. So this is going to be x plus h. So this little distance between x and x plus h is a distance of h. So you want to think of it as a very small amount. So f of x is right here. So this is a height on the function, and it's at a height of f of x. Now, this point right here, so maybe I can draw a dotted line up to it. So this point right here is on the function, and this is at a height of f of x plus h. That's how high it is at that point. And so suppose we wanted to find the slope between these two. So if I wanted to find the slope, I'm just going to write slope. And we usually use a letter m to represent the slope. So the secant slope, or the slope between these 2 points, is going to be rise over run. So rise over run. This is what we learned in algebra. And so the highest point is going to be f of x plus h. And we want to subtract the lowest point, so f of x, or you could say y2 and y1 if you want. So this is y2, the green one is y2, and the blue one is y1. And then we'll divide this by x2, which is x plus h, minus x1, which is x. And if I simplify the denominator down here, you'll see that we get a couple terms canceling, the x's, which leaves me with, we'll write it here in red, f of x plus h minus f of x all over h, which this should look very familiar to our formula. So this formula is nothing more than slope. It looks complicated, but it's not. It's just rise over run. And by taking this limit here as h gets closer to 0, so the limit as h goes to 0 is going to imply that this green point is going to get closer and closer to the blue point, which means that this red line is going to be what's called the tangent slope. So the slope at that specific point. Calculus is really all about that, is studying that infinitesimal slope and kind of trying to uncover its secrets, what it can do. And it turns out that the derivative, or the tangent slope, is very valuable. It's valuable money. So it's super important. So we want to find it. So we can it turns out we can find the slope of any function we want. So let's try to find the slope of this particular function, this parabola. And so the way that we want to do this is by plugging this formula, plugging the function into this formula. So let's go ahead and do that. So I'm going to write f prime, the derivative, is equal to the limit as h goes to 0 of, I'll go ahead and write the formula, f of x plus h. It's a good idea to write the formula just because it gets us in the habit of seeing the formula and practicing it. And so now let's fill in the pieces. What is f of x plus h? Well, that means we replace all the x's in f with x plus h. So this is going to be 2x plus h squared plus 5. And then what is f of x? Well, f of x is, we'll color code this. So f of x is going to be just 2x squared plus 5 all over h. Okay, and we'll continue down here. Now, we want to plug in h equals 0. So if you plug in h equals 0, you're going to end up getting 0 over 0. That will always happen with the definition of the derivative. So what we want to do is a little bit of algebra, some work, to help us find what this final answer is going to be. So let's go ahead and take our limit. Well, we're not going to take the limit just yet. We can't quite plug in 0. It doesn't work. So we're going to have to simplify by expanding. So let's go ahead and expand. I'll write this expansion here in black. So it's going to be 2x squared plus 2xh plus h squared plus 5 minus 2x squared minus 5. Notice I put parentheses around f of x, the green part. If you forget the parentheses there, this 5 will be positive instead of negative. So we have to put those parentheses around all of f. You want to subtract all of f, not just part of f. So we have to distribute that negative to each one of those terms. So that's why you see both of those as negative. Okay, so let's continue here. We can distribute the 2 in the numerator. I'm taking more steps than perhaps I need to, just to emphasize the process here, and hopefully so that I don't skip too many steps and lose anyone in the work. So here we go. What a mess. Expanding it just seemed to make everything look worse. So now let's see what cancels. This 2x squared is going to cancel, and this 5 and negative 5 will cancel, and I think that's it. So let's go ahead and write what's left over after the smoke clears here. Let's see, we've got 4xh plus 2h squared all over h. Okay, and so if you try to plug in h equals 0 now, you're going to get 0 over 0 still, unfortunately. So we have to do more work. So if you look in the numerator, notice that both of these terms have an h. So let's factor out that h. We have 2, oh, whoops, we're going to have a 4. So 4x, the h is gone, and we pulled out one of those h's. So this is going to be just an h. And then this h is still in the denominator. So I pulled out the green h there in the numerator, and notice this h is going to cancel. That's not a coincidence. That will happen with the derivative. So let's simplify. This is what's left over. And now finally, we can go ahead and plug in h equals 0. And we're just left with 4x. This is called the derivative of the original function, 2x squared plus 5. Or you could also call it the tangent slope. So that means if I wanted to know what the slope is, say, at x equals 3, I could plug in x equals 3 here and find 4 times 3 is 12. So the slope of this graph, of that parabola at 3, is 12. It's a pretty valuable formula. It's super valuable. It's extremely important in calculus moving forward, and I'm glad that we're able to look at it right now. So I'm glad that I even took the time to draw out this picture. Hopefully you took the time to try to understand the words that I was saying there. But let's go ahead and keep on moving and try another problem. I think the best way to learn these is to really get some experience. I'm going to write the derivative formula up here. So it's a limit as h goes to 0, f of x plus h minus f of x all over h. I believe you can also put a minus here, and f of x minus h, I think also gives you the derivative, if I'm not mistaken. So there are alternative formulas. There's another one that looks like this. Limit as x goes to a of f of x minus f of a all over x minus a. So this is an alternate definition of the derivative, but really I think the most important one for calculus that you will be using is this one here. It just is easier to evaluate, I think, is perhaps why we use it most often. So I'm going to put this in a thought bubble because it's probably something you should memorize, especially if you're going on to calculus next year. So I'm just going to say memorize. Yeah, you got to know it. You really got to know it. Come this fall, it's going to be awkward in class, I'm sure, just probably because we'll still be doing online learning. You'll have brand new teachers, and you won't even know who's in your class, just because of how class is working. I mean, maybe we'll be meeting physically. I don't know, but yeah. So a lot of this is going to be difficult for you, just because you're just going to have to commit a lot of this to memory on your own. It's going to be almost kind of like self-teaching yourself, even though I'm helping you now. But a lot of it's going to have to almost be self-taught. But hopefully I can help make it easier. So let's go ahead and try this one. So here we go. For this particular function, I'm just going to say f prime of x because we're trying to find the derivative. This is going to be the limit as h goes to 0 of, let's write f of x plus h. I'm just going to rewrite the formula again, minus f of x all over h. And I think I'm going to go horizontally this time. Limit as h goes to 0. Now this time, we're going to use this function. So f of x plus h is the first thing that we want to write. I think what I'm going to do is color code this a little better. So this one's going to be in green. So f of x plus h is 2 over, we want to replace this x with an x plus h, minus 1. Okay, so that was the first one. And now this f of x I'm going to write in red. So this is going to be minus 2 over f of x is just this, so 2 over x minus 1. So there's f of x plus h. That's this right here, f of x plus h. And here's f of x. And we're taking the difference, and then in the denominator, we just want an h. We want a blue h, ideally. There we go. Okay, let's keep going. So if you try to plug in h equals 0 right now, you're going to get 0 over 0. So we have to get a common denominator. So let's, in the next step, actually, let's try to maybe work. We'll try to work horizontally. So let's bring our work over here. I'll draw an arrow just so that I have plenty of space. So limit sh goes to 0. I'll draw an equal sign here. Is going to be 2 times x minus 1. So I'm getting a common denominator. This is x plus h minus 1 times x minus 1. So I had to multiply by x minus 1 on the numerator and denominator. And here this red one is going to get multiplied by x plus h minus 1 in the numerator and denominator. So what a pain. It looks super ugly. Hopefully it doesn't stay super ugly. This is going to be a minus 1. So there we go. So on the left, I multiplied by x minus 1 on the numerator and denominator. And on the right, I multiplied by an x plus h minus 1 on the numerator and denominator. There we go. Okay, all over h. What ugliness. So I think I don't like this fraction over fraction nonsense. So I'm going to write this as h over 1 and then multiply by the reciprocal. So in the next step, let's do two things. We'll get a common denominator between these two. So this is going to be 2x minus 2. I distributed this 2. And then minus, let's distribute this negative 2. It's a negative 2 that I'm distributing to all three of these. So it's going to be negative 2x minus 2h plus 2 all over this ugly denominator, x minus 1, x plus h minus 1. I'm not going to expand this yet, primarily because I don't want to. But the second reason is it turns out we don't need to. So I'm just going to leave it like that. Sometimes it's better to do just small bites at one time before you take on too much. So let's cancel some things. This turns out really nice. We get lots of cancellation. So in the next step, let's write what's left over. We're left with a negative 2h in the numerator. That's it. All over an x minus 1 factor and x plus h minus 1 factor. And then this h is still hanging out there. So notice that the h factor is going to cancel. That's very nice. We'll carry this down to the next line. Limit sh goes to 0. So here we go. We have what's left in the numerator is a negative 2 over an x minus 1, x plus h minus 1, and that's it. Now, so as soon as you get that h cancellation, we had so much cancellation here. As soon as you get that h cancellation, try to plug in again. So let's see what we get here. We're going to get negative 2 over x minus 1 times x plus 0 minus 1. And that's going to leave me with negative 2 over x minus 1 times x minus 1, or x minus 1 squared. So this is our final answer. This is the derivative. All right. Man, you guys are growing up so fast. Derivatives already. It's a big step in calculus, and by no means I should not should make it abundantly clear that this is very difficult. This is not easy. So if you're struggling with it, don't feel ashamed. I mean, this is a ton of work. Just look at what we're doing here. So this was that green fraction. This was that red fraction. We're getting a common denominator. We're expanding. We're simplifying. We're flipping, multiplying by a reciprocal. A lot of algebra here. So don't get confused either. What is difficult here? Is it the limit that's difficult, or is it the algebra? I would argue knowing what to do and knowing what algebra to do is the most difficult part. So knowing that you have to get a common denominator, that's first half the battle. Then finally getting that common denominator and simplifying is the other half of the battle. And really, after that point, it's pretty easy. You're just plugging in the slope there, or plugging in 0, and that's it. I mean, it's the hard part is the beginning. Let's not mince words. It is the hard part. So let's go ahead and try the next one here, number 4. Let's see how we're doing on time, just to be sure. Okay, not too bad. I like to try to keep it shorter, but let's keep going. So this next problem is going to take quite a bit of time. I mean, I think I might skip a little bit just to save us a little bit of time. So I'm going to start out by plugging in into the formula. So I'm not going to rewrite the formula this time. So here's the formula again, just to remind you. And let's go ahead and plug it in. So this is going to be x plus h. Let's color code it. I'll do it in green, just like I did before. X plus h cubed plus 1. And then we'll do a minus. And then this should just be f. So it's going to be x cubed plus 1. I need parentheses around it, though, because I need to subtract all of f. It says minus f of x. So we have to subtract all of f. And this is all going to be over h. So just a reminder, this is f of x plus h in green. And in red, this is f of x. Okay, so now there's no fraction really to get a common denominator between in the numerator. So the only option here is to expand. And that's the hard part. So expanding this x plus h cubed is a mess. So I'm going to go ahead and skip all the work for this and just write it down. So x cubed plus 3x squared h plus 3xh squared, and then plus h cubed, minus, we have an x cubed and a minus 1. I missed that plus 1 there, though, so let's see if I can get that in there. So let's scoot that over. I need the green plus 1. That was this guy right here. I forgot to keep him in the problem. And then this is all divided by h. Okay, so the way that I expanded that so quickly, if you watched last week's video or you were in class last week, you probably saw me use the Pascal's triangle, which is the binomial coefficients. So 1, 3, 3, 1. 1, 3, 3, 1 is the coefficients there. So that's much quicker than actually expanding that out by hand. So if you're having trouble expanding that out by hand, definitely come to my office hours on Tuesday at 10 and I can help you, or Friday, either way. But here we go. Let's continue down. Thank you. Wednesday and Friday. It's not Tuesday, but Wednesday. Yeah, Wednesday and Friday. Okay, so, or we could talk about it in class as well, so on Tuesday. But what's next? Okay, so we get some cancellation. The x cubed cancels, and that 1 that I forgot cancels. And let's write what's left over. So in the numerator, we're left with 3x squared h plus 3xh squared plus h cubed all over h. And then in the next step here, notice if you try to plug in 0 for the h, you're just going to get 0 over 0 again. So nothing has really been accomplished. So what we need to do first is factor out an h out of the numerator. So we've seen that before. It should look very similar. Let's go back. Remember when I factored out that h out of the numerator right here in green? So we did that once before on problem number 1, 2, whatever one that one is. So here we'd like to factor out an h again out of the numerator. So the process is very similar. So as to what we've seen before. So this is going to be 3x squared plus 3xh plus h squared. So one of the h's has come out. So each one of the powers is decreased by 1. And then we're left with an h in the denominator. And the h wipes out. And then finally, let's go ahead and plug in h into what's left over. So I'm going to skip another step here. I'm just trying to keep it as streamlined as possible and only show the essential steps. So here we're left with 3x squared. There it is. All right, and this is called the derivative. The derivative, or you could say tangent slope. It's really synonymous, same thing. All right, one more before we're done here. I think we maybe have like 10 minutes or so underneath my 45-minute mark. I'd like to try to keep it under that, so let's try to do this last one. Again, I'm going to write the formula. So here, I'm going to say f prime. Let's see if we can remember the formula. Maybe pause the video and see if you can do it on your own. But the formula, you should kind of be on your way to having it memorized. First of all, h goes to 0, and then it's f of, we want x plus h. Maybe I'll do that in green. Yeah, I'll color code this, why not? F plus h. And then we want to subtract from that f of x all over h. Okay, so let's plug in the bits here. So this is our function, square root of x. So in the next line, we would like the limit sh goes to 0 of square root of, instead of square root of x, it's going to be square root of x plus h. You replace the x with an x plus h, and we want minus. The function itself is just the square root of x, and this is all over h. Okay. Well, what an ugly function here. So what we're going to have to do is multiply by the conjugate in the numerator and denominator. If you try to plug in h equals 0 first, you're going to get 0 over 0. So we have to do something to get our work done here. So we're going to have to multiply by a conjugate on the numerator and denominator. So we have square root of x plus h, and this sign between the two square root terms will have to change. It's going to be a plus. Now, to keep it balanced, we have to multiply that by that same conjugate term in the denominator. So here we go. Now, like I said in class, multiplying by the conjugate usually makes it look uglier before it's going to look any nicer or any cleaner. So let's go ahead and FOIL or distribute. So multiply all of this out. So we're going to get x plus h. The square root is gone because you have square root of x plus h times the square root of x plus h. So it's square root of x plus h squared. And then we get this cross term, square root of, so it's going to be a plus square root of x plus h times the square root of x. And then here we get this cross term, so it's a negative square root of x times the square root of x plus h. And then we get this square root of x times square root of x, which is a negative x, since the front one is a square root, or a negative square root. So if you remember from class, I said that when you multiply or distribute a conjugate to its original term, multiply by a conjugate, you're going to get this cross term canceling. That will always happen with the conjugate. So it gets ugly, but then after the cancellation, it's going to get a little nicer. So this is going to be the square root of x plus h minus the square root of x, plus square root of x. So I didn't distribute this h through, I just left it alone. So let's maybe carry this down to the next line. You can carry it on down, but I'll carry it horizontally just so that we have plenty of room here to expand. I'm not wasting any white space here. So this is going to be x plus h minus x. That's what's left in the numerator, all over h times the square root of x plus h plus square root of x. And we see that the x's cancel. And now let's rewrite. We have an h over h square root of x plus h plus square root of x. And if you try to plug in h equals 0 now, you're still going to get 0 over 0. So we still have to do more work for some more canceling. And we see that this h cancels. That's good news. As soon as that h cancels, we can go ahead and plug in the h equals 0. So let's rewrite one more time, the square root of x plus h plus the square root of x. So this is going to be 1 over, when we plug in 0 for h, square root of x plus the square root of x. And the square root of x plus the square root of x, this is one square root of x, and this is another square root of x. So that's a total of 2 square roots of x. So this is going to be 1 over 2 square roots of x. Again, this is called the derivative. So notice that our answer here has a specific, or it's got an x value in it. So our answer is a function. So that function is called the derivative, or it's written f prime of x. So there it is, the derivative again. All right, very cool. So that was a lot packed into a very short lesson, a 40-minute lesson. Normally we would have done this probably over a full hour-and-a-half class period, and I would have given more examples. We probably would have done some in class together, like I would have had you do some. So it was perhaps less interactive than what we would have been doing in class, but that's why I'll see you guys in class on Tuesday and on Thursday. So I hope you understood the video, and if not, we'll talk about it in class. So thank you for watching.